Record. There we go. So last times we studied dynamic programming. All right, so why dynamic programming is very important because it is highly related to AI, especially reinforcement learning, RL. And there we go. So we can break down the relationship between dynamic programming and AI. So first of all, reinforcement learning foundation dynamic programming provides a theoretical foundation for many reinforcement learning algorithms. RL aims to train an agent to make optimal decisions in an environment to maximize a cumulative reward rate. So for instance, suppose you are using AI to create artwork, such as maybe the comic book or even a animation, right? So you want to use some certain tools to train the AI to give you better results every time, right? So therefore, RL reinforcement learning is one of those. And the model-based RLDP techniques are primarily used in model-based RL, all right? And the core algorithms like key RL algorithms, like a policy iterations and the value iterations, and the policy evaluation and the improvement DP methods are used to evaluate the goodness of a policy. So the goodness, or in the two-sum questions, can be like if there if there is a pair that can form the sum, right? Okay. All right, so there we go. And this is very important, very important. And of course, at natural language processing and NLP, while more modern NLP techniques often rely on neural networks, some older statistical NLP models methods use DP programming, dynamic programming for tasks like a sequence labeling and pair parsing. All right, okay. Now the game AI. In developing AI for games, particularly those with well-defined rules and states like board games, right? Dynamic programming can be used to calculate the optimal strategies or evaluating game states, such as chess, Go, and other games, right? Good. Okay, so, and then one of the example is to sum this question, all right? So the very original way is basically using two loops, right? So and then usually we'll be using a vector, res, something like that, right? And then you definitely need to have two loops here, right? And then I increments. So integer n is basically the size of the vector, right? Okay. And then for integer j starts at a 0 and then j less than n, all right? And then j increments. And definitely, all right, because it's checking the one next to it, so we can simply just shorten the range. And right here, if statement and else, no else, basically. Uh, and then if target is equivalent to nums of I and a plus nums of j, right? Then it is going to be a pair. And apparently j starts with I plus 1 because it's checking the one next to it, right? So and then for these rest period push back I and rest period push back j and then return rest. Then it is all good. And you also need to return rest here, right? If you submit these, it's supposed to be working because it is the most naive way to solve the problem. But the questions is too slow. So therefore, we wanted to make this program a bit smarter, right? Okay. So therefore, we need to reconstruct our data structures here. So firstly, we need to have this one. Let's say we have a unordered map, and it is going to be integer and integer data type. That is going to be called a memo here, right? Okay. And simply have these. What is unordered map, right? What is unordered map? I guess we have the definitions here, right? So yes, unordered map, right? And then all of these here. Okay, so this is the last class of materials. A map is the key and a pair, right? The key and the value pair. So therefore, and the for loop, uh, and the loop is a must, right? You have to have it, because you need to traverse the data structure, right? Okay. And then what's going to be the next step? Next step, first of all, you need to create a difference. All right. The difference is going to be target, subtract, subtract nums of the current data here, right? So therefore, it is like fx equals t, is like y equals t minus x, right? And where, okay, where x plus y equals t, right? It's like a mathematical formula here. All right. So we have the difference now. In your brain, you should think, okay, there's a chart, right? So for this part, you can close your eyes, or you can also stare at the screen. But basically, you need your brain to work, right? So right now, what you want to think is, all right, probably I need to traverse the what? I need to traverse the map first, right? So for instance, um, check if diff is in the map. Otherwise, push it into the map, right? Or write it into the map, right? Okay. So therefore, we need to have an if statement, right? Because we need to check. So therefore, first of all, it is going to be what? It's going to be a memo period of find, right? Okay. And from where to where is basically and the memo period end, right? Okay. So find what? It is basically find, we need to find the diff, right? Okay, so something like that. And for this, anyway, let's get over here. So therefore, memo period find the diff equivalent to end is a condition that value is to true if the key diff is not present in the memo, right? So therefore, this part is a must, right? So whenever you have a check, it's either going to be double equal, equivalent, or this, or that, right? The check is basically check the conditions here, right? Okay. So that's when there's no such data, right? So no data. Therefore, write into right. So memo and then it's something that's something, right? Okay. So you are saving, well, you are basically saving diff. There's a specific data here, right? Okay. And what do you want to return is basically nums of the it's going to be this. So these you basically use it now. I guess you are either saving I, right? Wait a second. It's I guess we need to push the diff right here and then place the what? I guess we need to plug the index, right? We need to plug the index. Makes sense, right? Does it make sense? So find a diff, and there's no diff, so we plug the indexing, right? Okay. So for instance, that, or we can push the original data itself. So for this part, it can be interchangeable here, right? Okay, so I guess we just use our official one here. Okay, so this is all right. So uh save the value to the key, right? There we go. And else, that simply means okay, there is a pair, right? If there is a pair, okay, so there is a pair. then return. So therefore, all we need to do is return. First one is going to be I. Second one is memo, right? Memo of diff, right? Because diff is already in, so therefore, it's basically diff is a previous piece, right? Okay, and then I see maybe I'll just put this one here, and then compile the code once again. This one should be no problem here, right? Then it beats 100%. So for these, all right, most likely cannot memorize the solution. If you memorize the solution, well, it never works because this is not like the for loop, the traditional traversal. Traditional traversal, you can memorize it because it's just a brute force. Uh, but for dynamic programming, you have to think while you're doing it. So I'm thinking, all right, if I save the diff here, right? Okay. Therefore, I think maybe I can also return these. So because, let's see. Okay, then there's a little problem here. So therefore, for these, you have to save exactly what you are supposed to save here, right? Otherwise, um, otherwise it doesn't make any sense to me though, right? Okay, there we go. Okay. So order really matters. Order matters. So therefore, as we can see, the principles of algorithm, right? So first one is sequencing, right? That means order matters. All right. That means yeah, the previous example is good, right? If I switch the order, no, it wouldn't work. And the second one is going to be iteration. Iteration is basically loop. And the number three is selection. Selection is basically the what? Um, the conditional statement, right? As you can see, order matters, traversal, conditional statement. All right, there we go. Good. And I'm going to update these once again. All right, so therefore, I want you to work on this a bit more. 31st, and then this is the code here.